All right, today's lesson is on solving quadratic equations by finding square roots. This is part one. There is a lot to this section, so I wanted to break it up into two. Okay, what you want to do is you want to take a look here at key concept, and you'll see that the product property says that you take anything that is inside the radical, you can break apart into two smaller radicals. Quotient property says that when a full fraction is covered by a radical, you can break it into two smaller ones, and we'll get into that momentarily. All right, before I start this lesson, I want to tell you that there are other ways that you can simplify radicals. You guys know my philosophy. You don't have to do it the way that I teach you. If you have a math tutor that shows you a different way that works for you, or a teacher in the past that has shown you how to do it, that is fine with me. I just know that the way that I teach this does help later in the year when we're doing cube roots and fourth roots, instead of this works for everything. Okay, simplify. Leave your answer in simplified radical form. You could easily reach for a calculator and use the square root button. However, perfect squares. I've listed your perfect squares over here. If you wanted to find the square root of 4, it's obviously going to be 2. The square root of 9 is going to be 3. You can find those on your calculator. A simplified radical form means that it's not a perfect square, so you are going to have a number outside the radical as well as a number inside the radical. So, knowing your multiplication tables are very important here. So the first thing step 1 says is find the prime factorization of the number under the radical. So in the case of letter A, we're going to find the prime factorization of 80. Now for those of you who forget what prime factorization is, it's a factor tree. Just about every number that you can think of is divisible by 2, 3, or 5. So as we go through this lesson and I am finding the prime factorization of numbers, I will usually use 2, 3, or 5 to start with. Even though by 10 or something like that. I always try to use one prime number when I'm doing prime factorization. So for example, two numbers that you can multiply together to get 80, one of them being prime. So you can do 2 times 40. And notice I'm writing them next to each other. Then what I do is I know that 2 is prime but 40 isn't. So I put a line through 40 and I write down what I can break 40 down into. That's 2 and 20. 20 is not prime, so I'm going to break it down to 2 and 10. And 10 is not prime, so I'm going to break it down to 2 and 5. Now, what are prime numbers? Remember, prime numbers are only numbers that are divisible by themselves or 1, so that way that they can't be broken down anymore. All right, step 2. Find the pairs and circle them in group. So I have a pair of 2's here, and I have a pair of 2's here. This 5 does not have a pair, so do not circle it. Step 3, multiply your circles together. Each circle counts as one number. The product goes outside of your radical. So even though there's 2 2's here, it only counts as 1 2. So basically what you're doing is you're saying 2 times 2, which is 4, and that number goes outside the radical. Because it is square roots, you're looking for pairs, and that's why we circled pairs. And then number 4, multiply any non-circled numbers together, and that product goes inside the radical. Well, in the case of this problem, so there is nothing to multiply together. So because it doesn't have a pair, it stays inside the radical. So that is your answer. And it can be checked by saying 4 squared is 16, and 16 times 5 should give you 80. All right, let's try that again. 98. 98 is even, so I know it's divisible by 2. So 2 and 49. 49 is not multiply 7 times 7 together. Now, I'm done. 7's are prime. I can't break them down anymore, so I'm pairs. I have a pair of 7's. That is the only pair that I have. And remember, it's one number. So that goes outside, because there's nothing to multiply it by 2. And then the 2 doesn't have a pair, so it stays inside. So 49 on the square root of 2 is your simplified radical. All right, now let's move on to C. If you'll notice, I have an option A and an option here. I don't care which one of these you use, whatever's more comfortable. I will tell you that I go between the two sometimes. I don't have one way that I do it. It all depends on the numbers. So option A is to treat each radical separately. So what you're going to do is you're going to look at 10. 10 breaks down to 2 times 5. Then you're going to break down 15. And 15 breaks down as 3 times. Once you break them down, you need to look at them as an entire piece. So that means, whereas up here in these, you were looking at groups like this, you have to picture this as 2, 3, 5, and 5. So there's your pair of 5s. So a pair of 5, 1 comes out, and you multiply the 2 times the 3 back together, and it's 6. So you're going to get 5 square roots of 6. Now option B is you can take the radicals and multiply them together. Well, if you recall, your rules for radicals say anything on the outside of the radicals get multiplied together, anything on the inside of the radicals get multiplied together. So 1 times 1 is just 1. 10 times 15 is the square root of 150. So by doing that, I find now I'm going to break down and find the prime factorization of 150, which again, remember I told you I always start with 2, 3, or 5 if possible. So it's going to be 2 and 75. 75 breaks down to 3 and 25. And then 25 breaks down to 5 times 5. You look for your pairs and you circle them. You only have 1, and that counts as a single 5, and multiply what's left back together. So 5 square roots of 6. So same answer either way. Now D, you'll notice, is a fraction that's all under a radical. But back up to the key concept up here, it says you can break it into 2 smaller radicals. So this one can be treated as the square root of 15 over the square root of 4. Now what do you notice about the bottom? Square root of 4, it's a perfect square, so we already know that the bottom is 2 and you're done. Now how did you get that? Because if you broke down 4, you'd get 2 times 2, there's your pair, it counts as 1, and it's out of the radical. And since there's nothing left over that does not have, there's no need to have the radical. Now 15 breaks down to 3 and 5. Both numbers are prime, and we do not have a pair for either number. So since nothing is circled, nothing comes out of the radical, so you just multiply those back together, and you put the square root of 15 over 2, and that's your final answer. So you just have to make sure that you're breaking down your answers. Okay, let's go one more before you're going to try out yours. Okay, this is another one situation, option A, option B. You can break them down as you see them. And if you'll notice, this is the first time we have something outside. Something outside just means when it comes out of the radical, whatever you bring out of the radical that you multiply together has to get multiplied by what's there. And we'll talk about that in a second. So you're still going to do the process. You're going to find the find prime factorization of 6, so 2 times 3. And you also have another 6, which is 2 times 3. So the combination of their prime factorizations together are 2 times 2 and 3 times 3. Find your pairs. 2 times 3 is 6, but remember, you're not done because it had a 4 out front. So if this is already existing out front, you have to do 6 times 4. So your actual answer is going to be 24. So that's your final solution to this problem. So anything that is already outside the radical gets multiplied to whatever comes out of the radical. Now option B was the one where you go ahead and you multiply your radicals together. So outside times outside, say 4 times 1, which is just 4. And the square root of 6 times the square root of 6 is the square root of 36. And those of you who know that you're perfect squares, 36 is a perfect square, so it automatically becomes 6. So then you're going to go 6 times 4, and that is 24. So again, 2 different ways to do the problem, same answer either way. All right, now it's your turn. If you're still not perfect at it, use your steps that I listed in part A, and it'll help you. Okay, go ahead and pause the video. All right, let's go ahead and do this. Now, one thing I want to tell you is your factorization may be different than mine, and that's okay. The final answer is what matters. So with this one, when you do your prime factorization, depending on what order, and again, your order might be a little bit different, when you're all said and done, the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. And remember, you can always check your factorization by multiplying these back together. So 2 times 2 is 4, times 2 is 8, times 3 is 24, and 24 times 5 is 120, so it checks. So you have a pair of 2's, and that's all you have a pair of. So the pair comes out and counts as 1. And then what's left under the radical is this multiplied back together. So 2 times 3 is 6, and 6 times 5 is 30. So the answer to this number 1 is 2 on the square root of 30. Excuse me. All right, go ahead and pause the video and do the next one.
All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next one. All right, go ahead and pause the video and do the next
Okay, now depending on how you did this, whether you did the breakdown of the 3 and left it, or if you did 27, you're going to get the prime factorization is going to break down to 3 times 3 times 3 times 3. And you have a pair of 3's and you have a pair of 3's, and 3 times 3 is 9. If you multiplied these back together, you would have saw that it was the square root of 81, and 81 is a perfect square, 9 times 9, so that's how you got your answer there. Okay, go on to number 3, pause the video. All right, let's look at number 3. Again, there's 2 different ways to do this. I personally would go ahead and break down each radical first, because if you did 24 times 10, you'd get 240, and that's a big number to break down. So if you had broken down 5 square roots of 24, you would have had 2 times 2 times 2 times 3. That's your prime factorization. And then you would have had 3, and then you would have had 2 times 5. So you're looking at your pairs. So you're going to multiply your 3 and your 5 together, and that's going to give you 15. Then you have to look at 1, 2, 3, 4 2s. So you have a pair of 2's here, and you have a pair of 2's here. So 2 sets is going to give you 4. So that means a 4 is going to come out, but the 3 and the 5 stay inside. But remember, you have to multiply this out. So 14 is 60 square roots of 15. And that's your final answer on that. And again, does not matter which way you do it, whatever one works for you. And if you have a little confusion, don't worry, you kind of have an idea of how to start it, and I can help you in class tomorrow. All right, now let's move on. This is rationalizing the denominator. There's a rule in math that says the final answer cannot have a radical in the denominator ever. So in order to eliminate the denominator, or I should say the radical in the denominator, you must multiply both the numerator and the denominator by the conjugate of the denominator. Sounds like a mouthful, but it's really not difficult. Okay, and these are your conjugates, and I'll refer back to them. Basically, in order to eliminate a single radical, you multiply it times itself. In order to do a number plus a radical, minus a radical. And in order to eliminate a number minus a radical, you do a number plus a radical. Now, mind you, I will refer back to this, and I will help you, so just don't panic. All right, step 1, we're going to simplify the square root of 5 over 2. Now, you might look at that and say, wait, I've already done that. But that was because the bottom was a perfect square, so this one's not. So I'm going to show you what to do. So what you want to do is you want to separate the problem into 2. So the square root of 5 over the square root of 2. Okay, well, the square root of 2, it simplifies out to 2 times 1, so it does not simplify at all. That is as simple as it goes. So what you have to do is you need to eliminate it. So this is a single radical. So up here it says if the form of the denominator is in a single radical, then you want to multiply the numerator and the denominator by that same radical. So the square root of 2 needs to get multiplied by the square root of 2. And what you do to the bottom, you do to the top. Now, when you do this, you're going to get the square root of 2 times the square root of 2. It should make a perfect square, which this does, because it becomes the square root of 4, which automatically becomes 2. So bam, denominator's taken care of, radical is gone. Then you need to go up here, and you're going to get 5 times 2, which is the square root of 10. All of this can be simplified. Now I happen to peek over here and notice that the 2 numbers I multiplied together and down or are prime, so I knew it couldn't be simplified. So the final resulting answer on this is 10, the square root of 10 over 2. So there's your final answer. Okay, let's do another one. Okay, 8 over the square root of 3. This is a single radical, so we need to multiply it perfect square, so you're going to do the square root of 3. And the rule for fractions says what you do to the bottom, you have to do to the top. So what do you get? The square root of 3 times, which is the square root of 9, which is a perfect square, which is what we want, because the square root of 9 is 3. Then up on the top, you want to do 8 times 3. But what do you notice? Do you notice 8 does not have a radical on it? This one is what I call outside the radical. This is inside the radical. You have to remember that anything outside the radical multiplies times outside the radical. Inside the radical multiplies inside the radical. So the resulting answer on this would be 8 times the square root of 3, and then 8 times the square root of 3. Now, you always want to check to make sure nothing simplifies. Outside the radical can simplify. 8 and 3, nothing can be simplified, but let's say it was 8 over 4, it could be simplified. But you can't, so that's the final answer. Okay, let's look at the next one. Obviously, the first step, break it into 2. All right, you know how I tell you there's an option A and an option B? I try not to get big numbers. So the easiest thing to do is to check and see if you can simplify. You want to see if the radicals can be simplified. Okay, and since we just talked about simplifying radicals, we should know that. How do we get 12? Well, that's 2, 2, and 3, and just to save time, okay, well, I shouldn't, let's do this. So it's going to be 2 and 6, 2 and 3. So there's my pair of 2s. So that's going to come outside the radical, and the 3 is going to stay inside. The 7 stays inside the radical because it can't be simplified. Now, if you'll notice, the only thing inside the radical is a 3. So that's the only thing that needs to be simplified. So don't worry about the 2 right at this moment. What you want to do is you want to go times the square root of 3 times the square root of 3. Now, what does that do? That gives you the square root of 21 over 2, 9. Well, the square root of 9 is 3, but remember, these get multiplied together. So the square root of 21 over 6. Now check to see if it can be simplified, but remember, the 2 numbers you multiplied here can't be simplified, so that's going to be your final answer. Now, if you wanted to do both of them multiplied by 12, you could do that. You're still going to end up with the same answer, except you're just going to be dealing with bigger numbers. And I don't know about you, but I would much rather break down a 12 than an 84 or 144 or whatever the number might be. Okay, now let's look at D. This one's a little bit different. This is a binomial. And referring back to the front page, this is 7 plus the square root of 2. Now here, this is where it's a number plus the square root. This is what is called a conjugate. And what you want to do is you want to multiply by the opposite sign here, the sign in between it. And you'll see when we FOIL them that it automatically drops those two middle terms. It's kind of like the difference of 2 squares. So what you want to do here is you want to multiply 7 minus the square root of 2. And again, what you do to the bottom, you do to the top. Okay? So this is going to be a FOIL problem. So what you want to do, and if you remember going back, if you want to use the boxes, you can FOIL if you want. I don't care. But I like this because it keeps it more organized for me. So I'm going to do 7 plus the square root of 2, and then 7 minus the square root of 2. And if you want to put a plus there to make yourself better, you can. Okay, now multiply together, fill your boxes. 7 times 7 is 49. 7 times the square root of 2. Remember, outside times outside, inside times inside. 2 times the square root of, 7 times negative square root of 2 is negative 7 square roots of 2. Then you have negative and a positive, so this box is going to be negative. Square root of 2 times the square root of 2 is the square root of 4. Okay, I'm going to pause for a minute because I'm going to show you what's the point of multiplying by a conjugate. These two are automatically going to be the opposites of one another. So those two are going to cancel. A negative 7 square root of 2 and a positive 7 square root of 2 are as opposite as negative 3 and positive 3. So those are going to cancel. And this last box right here will always end up being a perfect square. So this is actually changes to the square root of 4 becomes, and that becomes negative 2. The only two numbers, and I probably should have done my boxes bigger, are those. So what do you have? You have 49 minus 2, which gives you 47. Now this is the bottom, or your denominator now. Okay, we haven't done the top yet. So far we know that the bottom is going to be, or the denominator is going to be 47. Now the top is 3 times 7 minus the square root of 2. You're going to distribute, so you're going to do 3 times 7, which is 21. Minus 3 times the square root of 2. Outside times outside, inside times inside. So the final answer there is going to be that, and this is going to be your numerator, and that's going to be up on the top. So you're going to do 21 minus 3 on the square root of 2. And that's going to be your final answer. It seems like a lot of work, but trust me, you'll get so used to it that it won't faze you anymore. Okay, so this is 5 plus the square root of 6. Oh, so we're going to multiply by 5 minus the square root of 6. 5 minus the square root of 6. Okay, so again, binomial times a binomial, so that means it's going to be a FOIL problem or box problem, whatever works for you, whatever you're comfortable with. So I'm going to do 5 plus the square root of 6, 5 minus the square root of 6. So 5 times 5 is 25. 5 times the square root of 6 is 5 square roots of 6. This is minus 5 square roots of 6, and this is negative square root of 36, which automatically becomes 6. Positive 5 root 6, negative 5 root 6, so those cancel. So what do you have left? You have 25 minus 6. Okay, so when you get 25 minus 6, you're going to get 19. So the resulting 19 is the denominator of your answer. Okay, and then the numerator is just going to be 1 times 5 minus the square root of 6. You're going to multiply through, and you're going to get 5 minus the square root of 6, and that's as much as you can simplify. So that's going to be the top, and that's your final answer. Okay. Now, let's do another one. This one again happens to be plus. Now mind you, these were all plus examples. If they were minus, then you would multiply by 4 minus. If this was 4 minus the square root of 5, you would go plus. You'd multiply by 4 plus the square root of 5. You're always going to do the opposite of this sign. So what are we multiplying by here? We're multiplying by 4 minus the square root of 5. And what you do to the bottom, you do to the top. Okay, and the top's a little different, but we'll get to it. Okay, bottom is again a FOIL problem, so I'm going to draw my boxes here. So 4 plus the square root of 5, 4 minus the square root of 5. Multiply everything out. Square root of 25 automatically becomes 5. Negative 4 root 5 and positive 4 root 5 cancel. So what do I have left? I have this, which is 16 minus 5, which is 9. So the numerator of my answer is 9. Now I need to go ahead and do my top. So the square root of 2 times 4 minus the square root of 5. Now my guys, keep in mind the rules. Outside times outside, inside times inside. So this is inside, that's outside. So when you multiply this together, it's going to be 4 square roots of 2. Minus, these are both inside, so it's going to become the square root of 10. Check to see if anything can be simplified. This is just 2 times 5, so you don't have a pair, so nothing can be simplified. So the resulting answer is 4 square root minus the square root of 10 all over 9, and that's your final answer. All right, there's just a couple. Use these and try them now on your turn. Okay, you got 4 here, so pause the video, do what you can do. Again, I'm going to reiterate to you to see if you can simplify first. Like this one would be easier to simplify first. Okay, go ahead and pause the video. All right, step 1, separate into square root of 13 of the square root of 28. Well, I don't know about you, but I really don't want to do the square root of 28 and the square root of 28 because 13 times 28 is going to be a big, big number. So what I'm going to do is I'm going to see if I can simplify this. So 28 can be made by 2 and 14 and 2 and 7. So I have a pair of 2s. So yes, I can simplify it. So it can be simplified to the square root of 13 over 2 square roots of 7. That way the only thing I need to multiply by is this number right here, is the square root of 7. Because that way it makes your life a whole lot easier. Okay, so you're going to do times the square root of 7 times the square root of 7. All right, so what do you get on the bottom? You get 2. Actually, let me erase that. I'm going to go over here. Sometimes it's easier to go right. 2 times the square root of 49 over, or excuse me, that's on the bottom. 13 times 7 is going to give you the square root of 91. Now just keep in the back of your head, 13 is prime and 7 is prime. So neither one of this can be broke down. So that means that 91 is prime. So we're not going to break down 91. But the square root of 49 is 7. So you're going to multiply these together. So 2 times 7 is 14, so you're going to get the square root of 91 over 14, and that's going to be your final answer. Okay, so now we're going to move on to number 2. Go ahead and pause the video. All right, first thing you're going to do is you're going to separate it into 2, so the square root of 9 over the square root of 8. But what do you notice? You notice that the square root of 9 is a perfect square, so go ahead and change that to 3 right away. Square over the square root of 8. Then you need to see if it can be simplified. So you're going to do 2 times 4 and then 2 times 2. So you have a pair of 2's. That comes out, so you have 2 on the square root of 2 on the bottom and 3. Okay, I'm going to move down here for space purposes. All right, now the only thing I need to get rid of is this radical 2 here. What I do to the bottom, I do to the top. So that is going to be 2 times the square root of 4 on the bottom, and on the top you're going to do 3 on the square root of 2. Square root of 4 is 2. 2 times 2 is 4. 3 on the square root of 2, so that's your final answer. All right, now we're going to need to do the radical, so go ahead and pause the video a moment. All right, now this you need to multiply by the conjugate. So this is 7 plus the square root of 5, and remember what you do to the bottom, you do to the top. So 7 plus the square root of 5. This is going to be a FOIL problem, so go ahead and draw your boxes or do your FOIL the way you want to do it. So you're going to have 7 minus the square root of 5 and 7 plus the square root of 5. 7 times 7 is 49. 7 times the square root of negative 5 is negative 7 square roots of 5. 7 times the positive square roots of 5 is 7 on the square root of 5. And this will be negative square roots of 25. This cancels this. Negative square roots of 25 just becomes negative 5. So what do you have? You have 49 minus 5, which is 44. So that's the answer to your denominator. Now, the numerator is just a distributive property problem. Okay, you're going to distribute through. So you're going to get negative 42 minus 6 square roots of 5. And nothing can be combined, nothing can be broken down, so the resulting answer is negative 42 minus 6 square roots of 5. And that's going to be the final answer here. All right, one more. Go ahead and pause the video. All right, conjugate, this is plus, so we are going to multiply by 4 minus the square roots of 11. This is a FOIL problem. Draw your boxes or do FOIL, whatever works for you. Okay, I stopped talking because obviously you should be able to do this hopefully by now. It doesn't mean you're an expert, but you keep hearing the same thing over and over again. Only thing left is 16 minus 11, which gives me 5, which again is my denominator. My numerator is just simply a distributive property problem. Distribute through, so you're going to get 8 minus 2 square roots of 11, and that's going to be the top. And that's your final answer. All right, I'm not expecting you to be an expert. I'm expecting you to have a little bit of an understanding of how to do these. That's why I'm letting you do your homework in class, because that way you can get my help and you guys can work together. So use this wisely. If you have any questions, if you're not sure what I did in a certain spot, maybe highlight it, mark it out to the side so that in class tomorrow you can ask me for further directions. All right, have a good one.